You are tuned to Iri-e-learning, and I am your host, Teacher. In this acids, bases, and salts lesson, we will examine salts. Check the description box for links to all the videos related to this unit. By the end of this lesson, we should be able to define the term salt, relate the name of a salt to the acid from which it was made, state the properties of salts, distinguish between a normal salt and an acid salt. We begin with the first learning objective, in which we will define the term salt. A salt is formed when metal ions or ammonium ions, NH4+, replace some or all the hydrogen ions of an acid. We will use this animation to explain the definition of a salt. So here we have a molecule of sulfuric acid, which contains or consists of two replaceable hydrogen ions and a sulfate radical or anion bonded together. So the formula for sulfuric acid becomes H2SO4. H2, there are two hydrogens and the sulfate anion, SO4. Sulfuric acid is a dibasic acid where di means two, that is, it has two replaceable hydrogen ions. We just learned that a salt is formed when a metal ion or ammonium ion replaces one or both of the hydrogen ions, as it is for the case specific to sulfuric acid. For simplicity, we will use a metal ion such as the sodium ion, Na+, with the same one positive charge as the hydrogen ion. So it has one positive charge, just like the hydrogen ion, which allows for direct substitution. So if only one hydrogen ion of the acid is substituted, the salt formed still has one hydrogen in its chemical formula. So here we have one hydrogen ion being substituted by a sodium ion. So now we have sodium, hydrogen, and the sulfate ion making up this salt. And so the formula is NaHSO4, and the name of that salt is sodium hydrogen sulfate. The single hydrogen ion displaced will bond with an available anion to form another product, typically hydrogen gas or water. It would be good if you check the description box for the link to the lesson on reactions of acids for more details. However, if the second hydrogen ion is also substituted by the sodium ion, that is, all the hydrogen ions of the acid molecule are replaced, then the salt form does not contain any hydrogen ions. So for this salt, there are two sodiums and one sulfate. So we have Na2SO4 as the formula, and the name of that salt is sodium sulfate. Now, the two hydrogen ions that have been displaced in all, of course, will bond with available anions to form other products, and as we mentioned before, those other products are usually hydrogen or water. Just remember to review the lesson on reactions of acids. So check that description box for the link to that lesson. Now it's time to name salts. There are two parts to the name of a salt. The first part comes from the name of the metal or ammonium ion that replaced the hydrogen ion in the acid. The second part, or the end part of the name of the salt, comes from the name of the acid which was used to make the salt, or the acid from which the salt was made. Here we have a table showing the end name given to a salt based on the acid from which it was made. So our first one, hydrochloric acid, HCl, form salts that are called chlorides, and nitric acid, HNO3, form nitrates, sulfuric acid, H2SO4, form sulfates, and carbonic acid, H2CO3, form carbonates. Note, if the acid does not contain oxygen, as with hydrochloric acid, the salt name ends with the suffix ide, IDE. However, if there's oxygen in the formula of the acid, the salt name ends with the suffix ate, ATE. So just remember that simple rule. If the acid does not have oxygen in it, the name ends in the suffix ide, and if there's oxygen in the formula of the acid, the name ends with the suffix ate. So it's time for our first example. In this example, we are required to name the salt that has the chemical formula MgSO4. The first part of the formula is the metal, and if we are to look at the periodic table, Mg comes from a group 2 metal called magnesium. The second part of the salt comes from the acid from which it was made, and in this case it would be sulfuric acid. Sulfuric acid has a formula H2SO4, so SO4 would come from sulfuric acid, and sulfuric acid forms sulfate salts. Therefore, the name of this salt is magnesium sulfate. Our second example, we need to name the salt that has a formula Ca open brackets NO3 close brackets 2. The first part of the name comes from the metal. The symbol is Ca. Ca is the symbol for calcium. The next portion is NO3. Which acid has NO3 CO3 in it, and of course that's nitric acid, and we know that nitric acid forms nitrates. So the name of this salt would be calcium nitrate. Next example, Na2CO3. The first portion of our salt is the metal Na, which is the symbol for sodium. The next portion of the salt is CO3, and we know that comes from the acid, carbonic acid, which forms the salt carbonate. So as a result, the name of this salt is sodium carbonate. Here we have an example with NH4, and as we learned earlier, that is called the ammonium ion. So NH4 is ammonium, and Cl comes from the acid, hydrochloric acid, and we know hydrochloric acid produce chloride salts. So therefore, the name of this salt is ammonium chloride. In this next section of the lesson, we will state the properties of salts. First property, salts are ionic compounds. They consist of cations and anions. For example, magnesium sulfate contains magnesium ion and the sulfate anions bonded together ionically to form the MgSO4 molecule. The second property, salts are typically white solids. However, if they contain transition metals, they might be brightly colored. For example, copper-2 sulfate. Copper is a transition metal, and its ion in the salts generally gives a bright blue color, as shown here on our screen to the left with the example of copper-2 sulfate. Also, iron-2 salts are typically green, and iron-3 salts have a red-brown, or sometimes described as a rust-brown color. The third property, salts that are soluble in water form aqueous solutions that conduct electricity. These solutions are called electrolytes. Electrolytes conduct electricity because they contain free or mobile ions. Those are the moving charges, as we can see in our animation, and these moving charges carry an electric current. The same occurs when the salt is molten. In this activity, we will show that electrolytes conduct electricity. Here we have a series circuit. The ends of the external circuit terminate with zinc electrodes. The circuit will be completed when the electrodes are inserted into the distilled water in the container. The circuit also contains a light-emitting diode, LED, which is connected to two 1.5-volt cells in series, and the two cells together will make a battery. The battery functions as an electron pump in the circuit. We start with a control experiment by placing the two zinc electrodes in the distilled water. Make sure they do not touch. Note that the distilled water does not conduct electricity. How do we know this? The LED does not light up. Therefore, no current is passing through the circuit. We will keep the electrodes in the distilled water and add a few spatulas of sodium chloride. Notice the LED begins to glow as the salt dissolves in the distilled water. Why does the LED glow with the salt solution? Well, the added salt contains ions that separate as the salt dissolves in water. The free ions move around in the solution or the electrolyte. These moving charges or ions carry an electric current. The electric current moves from the solution or the electrolyte into the external circuit that consists of the zinc electrodes, the conducting wires, and the different electrical components attached within the single loop or series circuit. And just remember that the battery functions to pump the electric current or the electrons around the circuit. We just learned that some salts are soluble in water and they form aqueous solutions called electrolytes that conduct electricity. Well, there are other salts that are either partially soluble or insoluble in water. Here is a table that summarizes the solubility of the salts relevant to the course we are doing. Nitrates and hydrogen carbonates are all soluble in water. Chlorides, bromides, and iodides are all soluble except for lead and silver. However, the lead, chloride, bromide, or iodide tends to be partially soluble in hot water. Sulfates are all soluble except for calcium and silver sulfates, which are partially soluble in water, and barium and lead sulfate, which are insoluble in water. Next, we have carbonates. All carbonates are insoluble in water except for the carbonates of ammonium, potassium, and sodium, which are soluble in water. We're at the final learning objective, in which we will distinguish between two types of salts, normal salts and acid salts. Note that the salts discussed here are mineral salts and not organic salts. The inorganic salts include chlorides, sulfates, nitrates, carbonates, etc. So we're starting off with the normal salts. In normal salts, all hydrogen ions of the acid are replaced with the metal ion or the ammonium ion when the salt is formed. In other words, normal salts contain no replaceable hydrogens from the acid, so the chemical formula of a normal salt has no hydrogens in it. On the other hand, for acid salts, only some of the hydrogen ions of the acid have been replaced with the metal ion or the ammonium ion during the formation of the salt. Therefore, acid salts will contain replaceable hydrogens, and we will see these in the chemical formula for the acid salt. Back to our previous animation using the dibasic acid, sulfuric acid. Remember, if only one hydrogen ion is replaced in the acid, we end up with a salt that still contains the other replaceable hydrogen of the acid. And of course, the salt is an example of an acid salt, and the name of that salt is sodium hydrogen sulfate, and the formula is NaHSO4. Note how acid salts are named. It comes with the name of the metal first, sodium, followed by hydrogen, and then the name given to the salt as a result from the acid from which it was made. We started off with sulfuric acid, so the salt formed is called a sulfate. However, if both hydrogen ions of the acid are replaced, then we end up with a normal salt because there are no replaceable hydrogens from the acid remaining in that salt. And so the normal salt in this case would be sodium sulfate, and we learned how to name normal salts earlier in the lesson. You may have already deduced that monobasic acids, those are acids with only one replaceable hydrogen, will only form normal salts. They have only one replaceable hydrogen, and once that is substituted by the metal ion or the ammonium ion, they are no more present to form acid salts. Dibasic and tribasic acids, however, form normal salts as well as acid salts. Here we have an example of a dibasic acid, sulfuric acid, and we know it's dibasic because there are two replaceable hydrogens in each molecule of sulfuric acid. The number of replaceable hydrogens tells how many different salts can be produced by that acid. In the case of the dibasic salt, we know that there are two possibilities, one being a normal salt and the other being an acid salt. So when sulfuric acid reacts with sodium hydroxide, our first option, if only one hydrogen is replaced, results in the acid salt. So as we can see, there's still one of the replaceable hydrogens from the sulfuric acid present in the formula of the salt, and this salt is called sodium hydrogen sulfate. The next possibility occurs when both hydrogens from the sulfuric acid have been replaced, and as you can see, there are no hydrogens in the formula, and as a result, this is a normal salt, and the name of this salt is sodium sulfate. Now we're looking at tribasic acids, and we know it's a tribasic acid because there are three replaceable hydrogens in this acid. It's not an acid we have looked at before. This is called phosphoric acid, chemical formula H3PO4. Now this tells us, since there are three replaceable hydrogens, that there are three salts that can be formed, one being a normal salt and the other two would be acid salts. So when phosphoric acid reacts with sodium hydroxide, if only one of the three hydrogens have been replaced, we end up with an acid salt, sodium dihydrogen, di for two hydrogens, so sodium dihydrogen phosphate. So the salts formed from phosphoric acid are called phosphates. And this, of course, is an acid salt because there are two replaceable hydrogens from the acid remaining in the formula of the salt. So the next possibility is to have two of the three replaceable hydrogens substituted by the sodium. And so what we have is two sodiums now because it has replaced two hydrogens, and one hydrogen is remaining, and of course we have the phosphate part of the molecule. So the name of this would be sodium hydrogen phosphate. And of course it is an acid salt because there's still one hydrogen remaining in the formula. And the third option happens when all three hydrogens have been replaced by the sodium. Of course, course, this results in a normal salt because there are no more replaceable hydrogens from the acid in the molecule for the salt. So this, of course, is sodium phosphate. The hydrogens that were replaced combine with the OH of the sodium hydroxide to produce water as their second product. The lesson summary points are as follows. Salts are formed when some or all the hydrogen ions of an acid are replaced by metal ions or ammonium ions. The format for naming salts: we start with the name of the metal, followed by the name of the anion of the acid from which the salt is made. Salts made from acids containing oxygen end with the suffix -ate. Those without oxygen end in the suffix -ide. Hydrochloric acid form chloride salts, sulfuric acid sulfate salts, nitric acid nitrate salts, phosphoric acid phosphate salts. Salts are typically white solids unless they contain transition metals. Salts are ionic compounds that conduct electricity in their aqueous or molten states. Salts have different solubilities. All nitrates and bicarbonates, or hydrogen carbonates as they're also called, are soluble in water. Acid salts have replaceable hydrogens in their formula, but normal salts do not. Monobasic acids can only form normal salts. Dibasic and tribasic acids form normal and acid salts. It's quiz time. You have 5 seconds to answer each question after it is read aloud. Question 1. What is the name of the salt that has the chemical formula N2SO4? A. Potassium sulfate. B. Sodium carbonate. C. Sodium phosphate. D. Sodium sulfate. The answer is D. Sodium sulfate has the formula Na2SO4. Question 2. Identify the salt that is likely to have a color other than white. A. Copper 2 sulfate. B. Calcium sulfate. C. Sodium sulfate. D. Magnesium carbonate. The answer is A. Copper 2 sulfate. Recall that salts containing the ions of transition metals are usually brightly colored. Question 3. Which acid would never form an acid salt when it reacts with a base? A. Sulfuric acid. B. Carbonic acid. C. Hydrochloric acid. D. Phosphoric acid. The answer is C. Hydrochloric acid. Remember, hydrochloric acid is a monobasic acid, so it has only one replaceable hydrogen. Once that hydrogen is replaced by the metal ion or the ammonium ion, there are no more hydrogen ions available. Question 4. When sulfuric acid reacts with magnesium oxide, what is the name of the normal salt formed? A. Magnesium sulfide. B. Magnesium sulfate. C. Magnesium chloride. D. Magnesium hydrogen sulfate. The answer is B. Magnesium sulfate. The acid used is sulfuric acid, so therefore we know it forms a sulfate salt, and we obtain the name of the metal from magnesium oxide. The metal there is magnesium, so as a result, the name of the salt is magnesium sulfate. Question 5. Select the balanced equation that correctly shows the formation of the acid salt when sulfuric acid reacts with potassium hydroxide. A. 1 molecule of sulfuric acid reacts with 2 molecules of potassium hydroxide to produce 1 molecule of potassium sulfate and 2 molecules of water. B. 1 molecule of sulfuric acid reacts with 1 molecule of potassium hydroxide to produce 1 molecule of potassium hydrogen sulfate and 1 molecule of water. C. 1 molecule of sulfuric acid reacts with 1 molecule of potassium hydroxide to produce 2 molecules of potassium hydrogen sulfate and 2 molecules of water. D. 1 molecule of sulfuric acid reacts with 2 molecules of potassium hydroxide to produce 2 molecules of potassium sulfate and 2 molecules of water. The answer is B. Recall that the identifiable trait of an acid salt is that it contains at least 1 hydrogen in its chemical formula. With that fact, there were initially 2 possible options, B or C, as answers. Next, we check to see which equation is balanced. Of the 2 options, B has the balanced equation. The hydrogens are balanced because there are 3 hydrogens on both sides of the equation. There are 2 in the acid and 1 in the base on the left side of the equation, and on the right side there is 1 in the salt and 2 in the water. There is one sulfur on the left and one on the right, so the sulfur atoms are also balanced. There are 5 oxygens on the left of the equation, 4 in the acid and 1 in the base. And then on the right, there are 5 oxygen atoms as well, 4 in the salt and 1 in water. The potassium atoms are also balanced with 1 on either side of the equation. Since the number of each type of atom in the equation is equal on either side, the equation is balanced.
We have reached the end of our lesson. If you found this video helpful, remember to like, share, and subscribe. When you subscribe, you will receive notifications as new videos are uploaded. So until next time, I am Teacher with Iri-e-learning.